The core of what data scientists do is solving business case problems. It's not surprising that companies like Google, Amazon, and Meta will ask business case problems in their technical interviews. You might be a coder whiz or statistical savvy, but if you cannot solve business case problems, then you're going to struggle in data science interviews. So in this video, we're going to take a crack at business case problems together, and I'll show you techniques that can really be helpful for your upcoming interview. Let's get started. Now we're going to kick off with some practical tips that can be helpful for business case problems. The first tip I'd like to share is about the format of business case problems. There's usually 3 different ways business case problems can be provided to you. One way is the technical phone screen. So when you hop on a call, typically it's some sort of a technical assessment by a senior data scientist or a data science manager. And they might ask some SQL questions and some coding questions. Usually towards the end of the interview, they'll ask a 15-minute case problem where you have to solve a problem that's specific to the company that you're interviewing for. For instance, Lyft might ask in their technical phone screen about how to gauge driver satisfaction. And within that 15 minutes, you have to be able to think off the cuff and provide a response that is explained really well and provide a methodology that is statistically sound. And the second format is a take-home assignment. And this is something that a lot of startups will typically do because unlike large tech companies where they can just do a 45 technical phone screen and they can just put you right onto on-site, they're very resource constrained. And so a lot of the startups, what they will do is that they'll have a technical phone screen followed by some take-home assignment, which might take a day or 2 days, and then they'll have an on-site. And this take-home assignment might usually come in the form of some data files and some assignment that you have to solve. And what they might ask you to do is present the result in the on-site stage. Now let's talk about the last format, which is how the business case problems are done in the on-site stage. Now when it comes to the on-site stage case, there are 3 different ways business case problems are conducted. One way is just a simple whiteboard. Or nowadays, because a lot of the interviews are conducted virtually, then it will be on a Word document or some sort of interactive coding pad. And what the interviewer is going to do is they're going to give you a case problem, and then you have to flesh out an outline and explain your thought process on how you're going to solve it. Another type of case problem is that they might give you a printout of like a chart with some graphs. Maybe it could be a bar chart, maybe it could be a scatter plot, and then you have to interpret the result and address meaningful data science problems. And the last potential format, and this is something that I went through when I was interviewing for Google, which actually involved doing data analysis and building models on a Jupyter notebook. So in an hour, I was given some data set and I had to analyze some place stored data set, and I was asked to solve a set of 4 problems that involve data analysis and modeling, along with some presentation. And so depending on the company, the format of how they conduct the business case problem varies to an extent. But the general structure of how do you respond to a business case problem effectively still remains the same. So let me talk a little bit more about that. So when it comes to acing the business case problems, you want to ensure that you have a structured response. And this is something a lot of candidates often get it wrong. As soon as they're given a business case problem, like how do you measure driver satisfaction, they'll immediately dive into some sort of solution saying, oh, I'm going to use a survey, I'm going to implicitly measure it by using their activity and so forth. But you actually want to warm up by asking some clarifying question. You want to clarify the problem clearly and understand the parameters around it. And there are 3 types of things that you must clarify when it comes to clarifying the problem. The first is to understand the current business process. How are things solved as of right now? If you don't really know the process, then how are you going to improve it? The second process is understanding business requirement. When it comes to solving any data science problem, you don't just simply plug in a state-of-the-art algorithm without clearly understanding what is a business objective. And so the business requirement requires you to ask questions like, okay, what are we trying to predict? For instance, if you're trying to make a forecasting problem, what is the prediction horizon? What is the prediction frequency? There's a set of questions you must clearly define before you start the actual work. And that's what the interviewer is looking for. Can you clearly establish the business requirement before you actually dive into the solution part? And the third thing that's often overlooked is clearly identifying data sources. How are you going to do the data analysis or build a model if you don't have any information about data sources? So you might take a business case problem and the interviewer might give you some hints about what potential data sources you could use to solve this problem, or it's your job as a candidate to flesh all those details out. And these are the elements that the interviewers are looking for in almost every business case problems. Now, the part B of effectively structuring your business case problem is now fleshing out the technical part. So you've warmed up by clarifying the business problem. So the next part is to clearly flesh out what the technical solution is. And the steps are: talk about exploratory data analysis, followed by data pre-processing, followed by feature engineering, feature selection, model evaluation, and productionization. So these are the concrete 7 steps that you have to walk through when it comes to providing a solution to your business case problem. And we're gonna walk through this by a demonstration that I'm going to provide to you guys. Now let me briefly talk about the third tip, which is what are interviewers looking for. So essentially they're looking for 3 elements when they're evaluating you. One is communication. How clearly and comprehensively can you explain your details? The second thing is that they're looking for your analytical thinking. Can you take an open-ended, vague problem and define the parameters around it, deconstruct it, and think about what are the essential elements you need in order to solve that? The third problem is more like synthesis, so it's a problem solving. Can you provide a solution that is sound, that is effective to addressing this business case problem? So now that you understand the format, the structure, and the evaluation, now let's take a jab into a business case problem right now. Here's the business case problem we're gonna solve together. How would you predict flight delays? Many of us have been there. We're at an airport and we're waiting for our flight, and then the flight attendant makes an announcement saying that the flight's gonna be delayed by an hour, and you can hear a crescendo of sighs. So the purpose of this exercise is, can we build a machine learning application that can help predict flight delays? Now, in order to make the best use of this video, don't just passively watch it, but actually try the problem out and leave a comment below. The first 5 comments, I'll actually provide my own personal feedback about your response. Without further ado, let's get started. Alright, so as I mentioned before, in order to structure the problem, you want to start with some clarification. So watch how I clarify the problem in the beginning of this problem. In order to address this question, I think the first thing that I should do is clarify the problem. So in order for me to clarify the problem, I need to understand the following. So I need to first of all understand the current business process. And that really means that I have to understand what is the stages of a flight. And then I also need to think about what the business requirements are going to be. And then finally, I need to flesh out what data sources I have available in order to make this prediction problem. So the first thing I want to do is understand the business process. And part of understanding the business process is understanding the life cycle or the stages of a flight. And based on my current knowledge about flight is that there's typically 5 stages. So the first stage is a pre-departure stage. And the pre-departure stage is when the flight is getting ready to take off. So this is when the flight attendants are doing some security check, they're fueling the plane, and they're onboarding passengers. And then the plane gets taxied to a runway. So it gets taxied to runway. And this is just before the plane is about to take off. So basically the plane has already onboarded passengers and it's being taken from the gate to the runway. And then the plane takes off, and then the plane will be in flight for however many minutes, hours, and then it will land to the destination airport. And this cycle starts all over again. And obviously, this stage could be broken down into more nitty-gritty details, but overall, this should capture the essence of what a flight stage looks like, typically. Now, the next thing I need to think about is the delays part. So when we're thinking about delays, I think what we want to think about is the delta between the schedule versus the actual time that it takes to get to a certain stage. And based on my understanding, there's typically 2 checkpoints where the flight delays are being reported. So the next thing I need to do is I need to understand the meaning of delays in this case. So the flight delay is essentially the delta between the schedule versus the actual time. And over the course of all the stages of a flight, there are multiple points when it's either the flight attendant or the pilot that's announcing delays. And so we want to think about what is the prediction point. Do we want to think about predicting flight delays across all of the stages, or is there a particular point that we want to consider? And so that's going to be the first part of understanding the business requirements. So the prediction point of a flight delay. And I think that one of the 2 obvious ways of predicting flight delays is going to be the first part, which is during the pre-departure stage. So typically about 30 minutes before the plane will allow passengers to be on board, the flight attendant is going to announce in terms of whether the plane is on time or not. And so this could be a meaningful prediction point. So 30 minutes before the plane onboards passengers. And then the other potential flight delay point could be pre-landing. So usually about 30 minutes or an hour before the plane, the pilot might check in and say that the plane is going to arrive on time or not. And if it's not going to be on time, then it will talk about what the delays is going to be in minutes. So there's two prediction points where the flight delay could be predicted. And let's just say we're making this minimal viable product. I think the first prediction point that we want to focus on for this sake of exercise is going to be the pre-departure stage. So that's going to be the prediction point for us. And then the business requirement that we need to think about is the frequency of the prediction. So do we want to have a batch prediction and do we want to have a real-time prediction? And the difference between batch prediction versus real-time prediction is that batch prediction is you wait typically on a weekly basis or a monthly basis to generate the prediction. Real-time prediction on the other end is sort of like a REST API. Anytime you get a request for information, the model needs to basically spit out what the prediction is going to be. And in this case, flight happens on a 24/7 cycle. And so it makes sense for us to, I believe, tackle in a real-time prediction basis. And then the last thing I want to also clarify are the data sources that are available. And I would assume that I would have the following information. So I would assume that I would have signals like the flight ID, the aircraft info, such as the years in service, the capacity, the type of the aircraft, and the number of seats booked. And I would also have information about the actual departure time and the scheduled departure time. And the other time points I would also have are the actual landing time and scheduled landing time. Other information would include the gate number, the terminal number, and finally the airport name. Oh, and one thing I want to add is the company. So example, is it American Airline? Is it United Airline? And so forth. So all of this information, the business process, the business requirements, and the data sources provide information about what I need in order to solve this problem, which is predicting flight delays. Notice how I walked through the initial part. I don't just explain it verbally. I actually just jot down the thought process on the Word document. So this is something that's incredibly helpful for the interviewer to clearly understand your thought process, and it's also going to help you brainstorm. So if you are given some sort of coder pad or Word document, don't just try to verbally explain it, because that's gonna end up rambling. And so you actually want to structure it by creating a little outline. And also notice how I clearly defined the problem. I didn't just vaguely think about what the flight delay is going to be. I thought about it in terms of prediction point. I thought about the business process by doing a deep dive in terms of what is a life cycle or the stages of a flight. I try to clearly define the business requirement by talking about what the prediction point is going to be. Because if we're just trying to say we're gonna predict flight delay, notice how vague that really is, because depending on the stages of the flight, there are different flight delay checkpoints. And so clearly defining the terminology is very important. And this isn't just relevant for business case problems, but also product and specific case problems as well too. When it comes to measuring satisfaction or happiness or whatever the term that you're trying to measure, you have to clearly define what that term is qualitatively and quantitatively before you actually proceed to the actual technical solution. Now let's see what I do next. Now I hope you're enjoying this demonstration. And by the way, if you're preparing for a data science interview, make sure you check out datainterview.com. Data Interview is an interview prep platform created by data scientists for data scientists. For a monthly membership, you get access to courses including statistics, product sense, business cases, and mock interview videos. Also, even a Slack group community. As it's a living course, new content is constantly being updated every month. You can also get coaching and get paired up with a FAANG instructor like myself, an ex-Google, who will give you personalized prep based on upcoming interviews. Clients have used this to land top jobs at places such as Amazon, Google, and Meta. Make sure you check out datainfo.com and ace your upcoming data science interview. Now let's turn back to the solution. So as part of the technical solution, the first thing that you want to do is clearly establish the EDA and data pre-processing. So watch how I set this up. Now that I've gathered information, let me walk through the procedure of solving this problem using machine learning. So I need to think about the first thing, which is conducting an exploratory data analysis, followed by data pre-processing. And this is where I need to generate the label, format it. I also need to think about how I'm going to clean the data. And then I also need to do the feature engineering, followed by feature selection. And I need to train the model. And I need to do the model evaluation. And lastly, I want to talk about productionization. All right, so what am I doing with the EDA stage? There's essentially two things that I'm doing. The first thing I'm trying to look for is the model readiness. So essentially, what is the condition of the data? What's the missing value? Do I have any columns that are missing? Do I have any outliers? And depending on the state of data, I might think about what the proper data cleaning procedure is going to be. And I'll talk about a little bit more about that during the data pre-processing. And I'm also doing some initial set of exploratory data analysis, thinking about, all right, what are the distributions of the features that I have, the labels, and also doing some bivariate analysis where I'm looking at, all right, what type of signals are correlated with the label in this case. And then I might think about using some Pearson statistics and any sort of measure that help me understand the correlation between the target variable and the features. So some sort of a correlation analysis. Now the next thing I'll think about is the data pre-processing. So this is when I need to create the labels. So I don't have the labels right off the bat. Now what we care about is the delay of the actual departure time. So the label is going to be generated from the delta between the actual departure time minus the scheduled departure time. And the next thing I want to do is the data cleaning. So in the data cleaning stage, I'm basically looking at any sort of outliers or missing values on the labels, but I'm also looking at the data quality in terms of the missing values and the distributions across all of the potential signals that would be incorporated in the model. So when I'm doing data cleaning, what I would do is I would try to handle missingness with either imputation or deletion of columns. And what I mean by that is that if a column has really high missing value rate, let's just say 90%, then the field itself is somewhat useless at that point. So you might as well just delete the field. Now, I would impute it if it was maybe somewhere between 50% or less. And then the way I would impute it as a simple way to build this minimal viable product model is basically just doing some mean imputation, or I could use other techniques such as k-nearest neighbor or regression imputation as a way to perform that. And I would also handle outliers in this case. So depending on what type of model I'm using, whether it's going to be ordinary least squares model or some sort of like a tree-based model like random forest, how I handle outlier doesn't really matter, but it is going to matter in terms of labels. So I would presume that because this is like a real-time information, there could potentially be some bugs in the reporting. So there might be some instance where the flight delay information just doesn't make sense. It might be in the thousands or it might be negative. And in that case, I would think about what would be the appropriate procedure. So let's just say that for this exercise, I want to get rid of any positive extremes where the flight delay is hours 99999. So I would have some sort of a cutoff where I would have a 95th percentile cutoff where the appropriate treatment might either be some sort of a clipping or it could be removal of the row that contains such extreme cases. Of course, this might often require some conversation with the stakeholder to really understand why I'm seeing such extreme values in the label set. So this overall talks about what the data cleaning procedure is going to be. So notice I clearly established what type of exploratory data analysis I would do. I didn't go too much into the detail. I gave the interviewer just enough details to kind of give them a glimpse of what is the purpose of EDA in the case of business case problem. I also talked about how I would perform data pre-processing, including data cleaning and pre-processing labels. I didn't just clearly assume that I had labels given to me right off the bat. I clearly defined exactly how I'm going to derive the labels using the data source that I've outlined. So now let's see what I do next. Now let me talk about the feature engineering part. So it's not enough for me to just incorporate these raw signals with some data cleaning into the model. I would want to augment it with additional signals that could be useful for the model. So the first thing I would want to do is doing some sort of a time decomposition. So I know that in the time fields, I'm going to have the date and the time. And I want to be able to decompose that in terms of the month, day, hour, minutes, and seconds. And that information is going to be useful. And this decomposition is going to help the model interpret time. The next thing I want to do is doing some numerical encoding on categorical variables. The reason I don't just want to add the categorical variables into the model is because most likely stuff like gate number, terminal number, and airport name, there are going to be more than a dozen set of values. And if I were to just incorporate that into the model, then the model is going to suffer through something called a cursed dimensionality, which means that it has way too many features. And so in order to avoid that, I want to try to compress the categorical value by mapping into some sort of a numerical value. And the way I could do that is basically doing some aggregation. So I could do some aggregation like the historical average delays in minutes per gate. I could also do it at the terminal, and I could do it at the airport. So that information is going to help compress it. And I could also just be creative with it. I could use different window functions like the standard deviation. I could do min, max. I could also change the window length of the historical aggregation. So instead of looking at the entire lifetime, I could do it maybe the past 7 days, the past 14 days, and so forth. Another potential signal could be flight utilization. So I have information about the capacity and the seats that are booked. So I would imagine as there are more seats that are booked at a given capacity, it's just going to take a bit more longer time. And the next potential signal that could be useful is the flight utilization. And this is essentially the seats booked divided by the capacity. And I would imagine that higher this ratio, the longer it's going to take for the passengers to be fully onboarded on plane, thereby it might delay the actual departure time. And one final signal I might add are some sort of a lag-based feature. So for instance, I would incorporate the scheduled landing time versus the actual landing time. So I would take the delta of the two. And this is going to be the landing time before this plane is ready to basically onboard passengers and depart again. And if there's a delay in the landing time of a flight, then I would imagine that that is going to carry over to the departure time before the plane is about to take off again. And the other type of lag-based feature could be the delay in the departure time of the previous flight. So as I mentioned earlier, when it comes to flight, there's all these different stages, and if there's a delay at any point of that stage, then it will carry over from one stage to the next and onward. And so this lag-based feature could be helpful in predicting the flight delay for departure. So once I have the features that are ready, what I would do is do some feature selection. And there are multiple techniques to do feature selection. It could be PCA, it could be random forest, variable importance. It could also be L1 regression, like lasso, for instance. And so just for the sake of simplicity, I think the feature selection that I would use in this case is going to be L1 regression. Because this is also not only going to help me identify which predictors or which features are correlated with the target variable, but it's also going to remove multicollinearity, which is going to prevent overfitting of the model. Now, in terms of training a model, I'm going to keep it simple, and I'm just going to use random forest regression model. Of course, there are other type of models that I can use. I can use neural networks. I can use XGBoost. I could even use just ordinary least squares. But random forest is quick to train. It also comes at variable importance, which could be useful information in terms of understanding what signals are most useful in predicting the target variable. Now, when it comes to training a model, I would also think about hyperparameter tuning. So the hyperparameters I would care about is the depth of the trees. I would also think about the number of trees. And I would also consider the minimum sample split. So in these steps, these are the continuation of the 7-step procedure I talked about when it comes to solving technical problem. And it's the feature engineering and feature selection part. So I take the raw data sources and I really flesh out what additional features I'm going to extract from the raw data sources. Feature engineering, as you know, is a crucial component when it comes to building a high-performing machine learning model. And that's a key component that an interviewer is looking for when it comes to a machine learning case problem. And you'll also notice that I explained the feature selection process in details. I didn't just assume that I'm going to use the signals that are generated from the feature engineering and then plug them all into the modeling, because that would be a bit of a red flag given the curse of dimensionality. So I actually got into details about how I would select features using various techniques, such as the random variable importance, L1 regression model, and PCA. So far so good as you're following the video, and if these are the steps that you're going through in your solution so far, then that is awesome. Now let's continue the demonstration of what I do next. Now let me walk through the procedure of training a model. So first of all, I want to select the model that I'm going to use. And I'm just going to use a random forest regression model. Because a random forest regression model is relatively easy to train, it's easy to interpret, and it also comes with variable importance, which can help me identify signals that are correlated with the target variable. And I would also do some hyperparameter tuning. And the hyperparameters I want to tune are the depth of the tree, the number of trees, and the minimum sample split. So all of these are going to be optimized in order to find the right balance between the variance and bias trade-off of the random forest regression model. Once I set up how I'm going to train the model, the next thing I need to think about is how I'm going to evaluate the model. In order for me to evaluate the model, a really good way to do this is using k-fold cross-validation. This is going to help me understand what is the true error rate of the model. And in terms of evaluating the performance of the model, because this is a regression problem, what I'm going to do is I'm going to use the mean absolute error, or MAE. And I would apply this evaluation strategy across various set of the depth, the number of trees, and a minimum sample split. And in terms of doing the hyperparameter tuning search, what I could potentially do is grid search, random search, or hyperop. And typically, I like to use either random search or hyperop, especially if I'm searching for the optimal hyperparameters in an exhaustive way. So the model that results with the lowest MAE on the k-fold cross-validation is the model that's going to be used for the productionization stage. So when I'm productionizing the model, I want to build a REST API. And the reason being is that this is a real-time prediction. At any point I receive some sort of input, the model needs to generate the output. So the REST API is going to be helpful. So what this REST API is going to do is it's going to receive a set of input, basically the feature signals that I need in order to output the model prediction, which is going to be flight delay. So I receive this input in form of array, and this is going to be fed into the model, which is going to produce an output. And in terms of the data format, it could be JSON. And this REST API is always going to use the latest model version. So the model is going to be trained, let's just say, on a weekly basis. As new signals come in, there's more data. And so it makes sense to retrain the model on a new set of data. Just train on a weekly basis. And what's also important is that because it's a real-time prediction, latency matters a lot. And we always want to ensure that we're able to deliver the output fast. And so one way to do this is model caching. And what model caching is going to do is that instead of retrieving the model from storage, which takes time, it's always going to ensure that the model is in RAM. And so thereby it's able to generate prediction much quickly. And the next thing I would want to do is storage of the inputs and the outputs and the model. So storage, the input, the output, and the model. And one thing I just want to quickly add is that when it comes to storage on the inputs and outputs, you could just store it in, let's just say Postgres SQL. And the last part is monitoring. So this is important because I always want to ensure that the health of the model is sound. I'm checking for the latency. I'm also checking for errors. And I'm also looking at the performance history. And this is why storing the inputs and outputs are important because it's going to help me understand what's been the historical performance of the model. And if there's a decline on that, then I would have some sort of like a alerting. So if the performance is declining, then alert the end user so that they know when to retrain a model or just change the strategy overall in order to ensure that the model performance is really good. So now I've finished the rest of the procedure by talking about the model training, the model evaluation, and productionization. Now, I just want to briefly talk about the last part, which is productionization. Now, depending on the candidate's level of experience, some interviewer might ask you additional questions about productionization, who may not have industry experience in productionizing machine learning problem unless they've had internship experience. So for the most part, explaining the first 6 steps are the crucial component, and the 7th step is really the icing in the cake. And if this is the part that you can explain, then that is awesome. Now let me talk a little bit more about the training model. So I did a good job in explaining what model I'm going to use, and I also talked about the hyperparameter in terms of the parameters that I'm going to search, along with what the search strategy is going to be. I also talked about the evaluation. I didn't just presume that I'm going to build a good model. I talked about what is the evaluation criteria I'm going to use and how I'm going to evaluate it using K-fold cross-validation. So overall, I've hit all the key elements when it comes to effectively responding to a business case problem. I clearly established the problem by clearly defining the term in terms of the business process, the requirement, the data sources, and I walked through the 7 steps of building a machine learning model. Take the time to compare the demonstration in this video and your own response, and think about what qualities you already possess when it comes to business problem and what qualities you need to improve. And as always, just keep practicing. Business case problems are hard. It's often somewhat awkward to practice. But believe me, when I was a data science interview candidate in 2019 and 2017, I practiced case problems almost on a daily basis, and that was crucial for me in order to ace data science interview at places such as Google. So if you suck at it right now, don't worry about it. Practice on a daily basis, get engaged with me on the comment section, send me an email with some questions, dan@datainterview.com, and stay tuned for the next video because I'm gonna have another follow-up video that gives you a demonstration of another business case problem. Now the last thing I just wanna say here is that when it comes to most technical interviews, there's the business case component and there's also the SQL component, which is very popular for interviews like the Google's product analytic role, but also Meta's data scientist role. So make sure you check out this next video, which will give you a deep dive in terms of how do you respond to SQL problems effectively so that you can ace your upcoming interview.